Hello everyone, welcome back to the course. In today's lecture, we learn about JavaScript objects. JavaScript objects are everywhere. If you think about arrays, functions, these are all objects. Even the console.log that we use is a method inside an object. Let's start simple. What is an object? Object is simply a collection of key value pairs. You can think of them as dictionaries in Python. You have the keys, which are like labels, and the values that can be anything from a string, a number, to an array, or even other objects as well. The simplest way to create an object is using the object literal syntax, which is defining an object inside curly brackets with keys and values. And here's how we can make one. In this person object, we have three different keys. These keys are called the properties. We have three properties: name, hobbies, is student. All the keys are strings by default, but you don't have to put quotes unless there is a space or a special character in between. To access the value inside the key, we have two different way. One is the dot property, one is using the square bracket. Here we can get the value of property name using the object dot name, or we can also use object bracket whatever property name that we want, and that gives out the value of the object. Why two ways? Well, bracket notation allows you to use dynamic keys. Creating and updating the value is pretty simple. We can directly say the object dot a property equal to something, that if it's there it will update the value, if it is not there then it will create the value. For deleting the key, we use the delete keyword, and we can specify what property we want to delete, and then we can directly say delete that property. Done. Let's head over to the editor to get this in more detail. Here on the right hand side you will see all the output logs. Let's get started. Let's create an object, const user. This is the object name. Then we can add different properties that we want. This is using the object literal syntax, since we are defining it within curly brackets. So I would say a name, hobbies, let's say coding, what else, is student. We have a string and we have a boolean. For creating a new property in this user object itself, we can directly say user.city. Let's create a city property, Chennai. So now if I print this user object out, you would see I would get a city as well. Let's see that in action. Yes, definitely. You can see we have a city, we have hobbies, is student, and name. All these things got added. If I want to update this, I can again say user dot hobbies equal to something else. I would say swimming. And now my object, instead of the hobbies being coding, we have the hobbies as swimming. So this is how we can create and update properties. To delete a property, we can again say delete user.hobbies, and then at the end we will console.log that out. So now if I see, I don't have the hobbies property, it's gone. Okay, so we can do this. Now here's something wild. Remember we said the values can be anything, they can be objects as well. The values can be objects as well. So let's create a value that is an object. So let's have a profile. That is another object. And then the username. Let's have a username in here. In the profile, let's have a username and something else. Let's have number of followers. So now my user object has another object inside it, the profile object. How do we access the values? We simply say, if I want to access the username, I would say user dot profile. User has a profile, user dot profile, and dot whatever you want. If I want to access the username, I can access it like this. And if I print that out, you would see buffered reader. The username came. JavaScript allows you to go as deep as you want with the chaining. Although if you go one level deep, if something does not exist, you would get undefined, And if you go one level above that as well, you would get an error. So here's where a helpful feature comes in that came up in ES6, the optional chaining question dot. This allows us to safely access properties. If the property is not available, then it will not go. Suppose if I log console.log this particular value, what would I expect? The username does not have a .a property in it, so I'll get undefined. But if I go one level above that, I say a.b, then I will get an error username is because username exists, but it does not have a .a, you get undefined. And if I try to access a property of undefined, this gives me undefined. And if I try to access a property of undefined, then I'm getting an error. Let's see. Yes, I'm getting an error. But what if I say question mark dot? That means only access the a when username exists. So in this case, username does exist, so it will try to access a. But only if a exists, try to access b. So in this case, this will not give me an error because a does not exist, so it will not go to the dot b of a. So let's try that. We still get an undefined, but we don't get an error. In this way, it does not crash your code if a property does not exist. Now let's talk about methods, one of the most important things related to an object. Methods are just functions that are attached to objects. Instead of having the property value as either a primitive in our object, I define it as a function. Let me create another object. Let's have a car. It's a Toyota car. Let's have a start property. But now I'll say now it's a function. Since the function, now this becomes a method. So methods are basically functions that are properties of a object. I will say console.log car started. To call this method, I'd have to say car dot start, and car dot start and adding a parenthesis. So this is the way to call functions. Similarly, the way to call methods is the same. We have, since it is a property to object, I would say car dot start. So if I do this function should run. Let's try that out. Yes, car started, this function ran, and we are good to go. Now let's talk about this keyword, which is very important when we are talking about objects and methods. Whenever a method is called as a property of an object, for example car.start, the object to the left hand side of the method becomes the this inside the function. So if I print out or console.log this over here, this, that means since I'm calling it as a method to this car object, then this becomes this inside the function, or this inside the method becomes the whole object, this whole object. Let's see that. First we are getting this. So as you can see, we have everything. We have the brand Toyota, the start function. That means this is the whole object itself. This keyword is very important. It allows you to change or access the property of the object which is calling it. Suppose I want to change the brand or look at the brand of what the object is. Now I would say this dot brand. Let me comment this out. So now you can see Toyota. And if I want to change the brand, that also I can do this dot brand equal to Maruti. So this allows us to change. This allows us to access the object which is calling the function. This is how it works for regular functions. For arrow functions and for other permutations and combinations with this, we'll explore the differences in detail in another video. Object literals are not the only way to create functions. There are many more ways to create objects. One of the modern ways to create one is using the class and the new keyword. Let's create a different object. Let's create a new object using the class. Let's create a class dog. By convention, classes are named with Pascal case, capital letters in the front. It takes a constructor. The constructor is the first function that is called whenever we define a new instance of this class. So what do you want to initialize this dog with? So let's have a breed and a name of the dog. So these are the values that we have to provide whenever we are instantiating a new dog. Class itself is like a blueprint which defines what is the features of this object, and when we actually use the new keyword, that's when we create an actual object of the class. So here again this comes up. This refers to the object which will be calling. So this dog breed equal to the new breed that we gave. This dot name equal to the name that we gave when we are instantiating the object. Let's also create a method over here. This is a method, and we can console.log something, console.log. Okay, the dog says woof woof. So whenever I'm trying to get the property of the object itself, then have to use this dot name. This is the blueprint that we have defined. So every object that we create using the dog class will follow this kind of structure. Everyone will have a breed, name, and a function speak. So let's actually create an object and see. Dog1 is there. We call this using the new keyword and then dog, the name of the object. And then using the new keyword and the name of the class dog, whatever we had defined in the constructor, we will give it there. The breed, let's have husky, and name Hachi. Let's have another dog too. This is German Shepherd. No, name is Bruno. So as you can see here, using one single class, we can define multiple different objects in it. This is another benefit of using class-based object creation. We define it at one place, and all the objects that we define using the class follow that same structure. When I say dog1.speak, this function will be called for dog1. So this for dog1 would be the dog1 object itself. So dog1.name says woof woof. Dog1 is Hachi. Hachi says woof woof. That's what we should get, and that's what we get. And if I say dog2.speak, I'll get the same thing with Bruno says woof woof, right? That's how we can define classes. If I want to extract a particular property from dog1, I can say dog1 dot whatever property name I want. In our case, we have breed and name. So I will say dog1 dot breed. This will extract me a property name. And what if I want to print it out? Simply console.log whatever I wanted to print out. If I save this and reload, husky, right? That's what our dog1 breed is. Okay, so this is, at the end of the day, it gives me a similar object like we created in the object literal syntax. There are a lot of times where we want to have a certain property that I want to extract and use as a variable. So in our case, what we can do is create a variable, const suppose name, and set that to the property of the object, dog2.name. So in my case, name would be Bruno because dog2's name is also Bruno. But here's a cooler way to do this. Instead of using this syntax, we can say dog2, extract the property of dog2. This curly brackets tells me extract the property name from dog2. And instead of putting name over here, I say const name equal to dog2. So this does the exact same thing, creates a variable called name and extracts the name property from dog2. So if I log it out, you'll see I get the name again, Bruno. That's what we got. This is called the object destructuring. A lot of times when we have a huge object and we want to just use a certain function or a property from that object, we do this object destructuring in order to easily use that property or a function. If we want, we also can rename the property that we want to extract. So what I can do is say I want to extract the name but rename to something else, like my dog name. I want to rename and then assign it to the object dog2. In this case, it will extract the property name from the dog2 and create a new variable in my current scope with the name of my dog name. And if I console.log this, you will see the name of the dog, my dog name, Bruno. This is called the object destructuring. One last but very important thing about objects is objects are reference types. That means if you assign an object to another object, they will point to the exact same object. Let me demonstrate. A is an object with a value 10. Value is a property and the value of value is 10. And if I say const b equal to a, that means now a and b are pointing to the same object. Now a and b are pointing to the exact same object, whatever we have described in the curly braces. They are not copies of the object, rather they are pointing to the same object itself. The consequence of that is if I change any value in a or b, the changes would be reflected in both of them. So if I say a dot value equal to now 20, if I change the value of a later at a later point of time after I have assigned, doesn't matter because a and b are pointing to the same object. And if I console.log object b, you'll see something crazy, right? The value of b has also been changed because now they are pointing to the same object. If you want to clone this object at this point of time, there is another special syntax for it. We use the spread operator. Dot 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 3 spreads operator. This basically means take any object and open it up, spread all the properties and values. So in my case, if I say a equal to spread a and put it inside an object. So all the values of a are spread and then put it inside an object. That means it opens up the brackets, puts all the properties. So suppose I have multiple properties. Then it spreads out all the different properties of a and b gets the value. So now if I change anything in a, that means the changes will not be reflected because now this has made a copy of the objects. Now it has made a copy of all the properties. As you can see, I had changed value of a, which is 20, but value of b that we had printed out is still 10. And just to demonstrate, I'll also print out a as well. As you can see, a is 20 and b is the value is 10. That means now we am getting a copy of that object. Although this creates a shallow copy, meaning only the first level properties are copied, not what is underneath it. So suppose I have an object here or an array here. Array is also a reference type. So ingredients. I have these ingredients. That means when I spread it out in B, value and food, this will be copied. But ingredients, since that is another object or another reference type, that will not be copied. That will be added as a reference again. That means any changes I do to A dot ingredients will also be reflected on B dot ingredients. Let's check that out. If I change something, A dot ingredients dot push, I'm adding a new ingredient, cheese. I'm adding a new, I'm adding one more object, I'm adding one more ingredient to this ingredients property. Then if I print that out, you see the top one is the A array, the bottom one is the B array. You see this is not reflected. Any changes to the primitive is not reflected, but any changes here, I added cheese, that is also reflected in here. That means it's a shallow copy, meaning any reference types there are, they will still be copied as a reference. Only the first level of properties will be copied. Anything nested inside it will still be as a reference. That is called a shallow copy. I'll leave it as an exercise for you to figure out how to do deep copies, and see you in the next one.